Okay, now we're going to learn something new today. Write a compound inequality that represents the phrase. Now, we are not doing this for every problem, but I want to help you understand what you're doing. All real numbers between -7 and 27. So in this little box, you're not doing this for every problem. I want you to put a -7. I want you to put a 27 kind of far out. Now, in between them, I want you to pick a number in the middle of those two. Well, let's go with +10. So if I'm going to put a symbol between these two, it has to eat the 10. Okay? If I put a symbol between these two, it'd have to eat the 27. So look at those signs. Eats the higher number, but then it eats the 10. Now, what we do when they're talking between, we put X and then we put -7 on one side, give yourself space, and then 27 on the other side. And those signs, you're always going to eat the higher number, but then you're going to eat the X. Now you're going to put lines underneath them because it can be equal to either one. And that's it. Okay. Okay, and that's how you do between. It's pretty well cut and dry. It's that way every time. So let's put X, and then we'll put the lower amount here, the higher amount here. Then we eat the higher amount, then we eat the X. Okay, and I showed you why those signs line up like they do right here. Put equal signs though. Don't have to graph them, just write the inequality. Okay, between. So X, 200 and 900. You can put another letter if you want, S or whatever for square feet. I don't care. But we eat the 900, then we eat the X. Okay, both with equals. Okay, next. Let's put P. You can use P for prices. You can also use X. I don't care. Okay. It doesn't matter the variable. Okay. If you want to use a P, that's fine. So 1875. So we eat the higher number, then we eat the X. Those problems are easy. Pretty much walk in the park. Okay. Now these problems are easy too. Now you're not looking at a phrase, you're looking at a graph. Now you're going to wonder what's up with that, okay, but I'll get to that. X would be any number between -2 and 6. So we put X, don't put 0 on this, okay? 0 does not belong here. 0 is just there to give you a sense of where the numbers are at. So you got -2 and 6. So we want to eat the 6, and then we want to eat the X. Okay, we will not be putting equals to signs because they're open circles. That's the answer. Okay. Now, this time the arrows are going apart. They're not coming together. So it's X can be anything but what's in between here. Okay, it can be any number that way or any number that way, but it can't be what's in the middle. So here's how I label that. I write the word or. Okay. You just put on an OR graph, you put X separately, okay? Then look at the board. When we go this way, okay, we go this way, we have to eat the X. It's open, so don't put a line. Now put -4. When we go this way, okay, we have to eat the number. That's all you do, okay? X less than -4 or X greater than 10. All right, now this is another between where it's all one line, okay? So you put X one time, -5, 16. Then you eat the 16, then you eat the X. That one needs to have the line because it's closed circle, and so does that one. Okay, they go apart, so that's OR. On OR graphs, you put X, X, then you just follow the rules. When the arrow goes that way, we have to eat X, put the symbol. When it goes that way, we put 7 down, we have to eat the number. If you put 7 in front of X, that's fine, but you got to eat 7, okay? All right, we're going to do some more in the back. So X, they go between, it's between, okay? It's either a between or an or. Betweeners, you write X just down once, you put that number and then this number. Okay, so we eat the -3, then we eat the X. Both of them are filled in, okay? Because if you pick a number between there, okay, you don't have to do this, but If I put -10, -3, pick a number in between, let's go -8. -8's bigger, but then -3 is bigger than -8. Okay, that's why the signs line up like they do. Okay, this is an OR, so we put X and X. We put 2 going that way eats the X with the line because it's a closed circle. -2 going that way eats the number with a line because it's a closed circle. Okay, this is an OR. Okay, so X, X, 20 going that way eats the X. We don't put the line because it's open. This way eats the number. Okay, no line because it's open. Now this is a between. Okay, so we put X, we put -7 on one side, 20 on the other. So we eat the 20, then we eat the X. Okay. Alright, so far I'm not doing a lot of math here. Okay, now your math starts here. Solve and graph the inequality. This looks a little bit different. You are going to make a table here. How do you know you make a table? Well, that would be because there's 2 inequality symbols in the same problem. Make the table. Now, make the table. Now I'm going to give you a little demonstration. You don't have to take notes, just watch. I'm going to guess a number for X. I'm going to write this out. You don't need to write this, just watch. Now I'm going to say X is 5. Maybe 5, yes or no? So I'm going to put 5 in for X. What's 5 plus 6? I think it's 11. Okay, does it eat the bigger number here, 7, 11? Yes, it does. Does it eat the bigger number here? Yes, it does. So 5 is a yes. It's a solution. Now, what I'm trying to find is all the numbers that would be yes. Well, that's going to take forever, so that's why we want a quicker way of doing it. Here's what I do. You need to start a circle and stop when you get to the second symbol, okay? And you just copy that down. 7 less or equal to X plus 6. Then move over here. Now you start your circle at the 12 and stop when you get to the other symbol. You are going to put X plus 6 less or equal to 12. So X plus 6 is in both of these, okay? So 7 with that symbol with X plus 6. Then X plus 6, that symbol with 12. Now we solve them separately, okay? Make your wall. If you want to put a 1 in front of the X, that's fine. Put a dot circle, that's fine, okay? But it's a keep, okay? So you minus 6, and then go minus 6 from your 7. So the sign's going to stay the same, we know that. So we put X behind where it's at. 7 minus 6 is 1. Now if you have a 1 in front of that X, that's fine. You'll just divide by 1, but you're dividing by a positive, so it doesn't matter. Okay? Don't graph that yet. Okay? Go find the other part. Okay, there's a plus 6. Okay? So it's a keep. There's no multiplying, dividing unless you put a 1, but it would be positive, so that'd be a K for keep. Okay, you need to get rid of your plus 6 though, okay? So you have X, 12 minus 6 is 6. If you have a 1 dot, you just divide by 1, it would still be 6, okay? That's fine. So 1 and 6, plot those numbers down. They can both be on the same side of 0, it's not a problem. Make circles. You're going to close them both. Now, look at the board. When it eats X, it goes this way, but just make a small line. When it eats a number, it goes this way. Okay. Now, I want you to label your graph. Remember how we just got done labeling it? We put X in between the two. Okay, I didn't leave enough room. That were words in the way. And then 1 on this side, 6 on this side. We eat that, then we eat the X. Okay, that's how you label a between. Okay, next one. It's pretty much the same thing. You see 2 symbols, okay? So you're going to drop them both down into your table. That one doesn't have the line. So I start my circle and I stop it when I get to the second symbol. So I have -3 and then X minus 4. Then I make another circle. we're going to have x minus 4 and then negative 1. Then I solve them separately. Okay. So x is on this side. You can put a 1 if you want, but it's a keep. Okay. I'm not a fan of subtraction. Make it plus negative. Then you add 4. Add 4. That's going to be 1. And then you got x. So if you have a 1 in front, you just divide by 1. It'd still be 1, but keep the x where it's at. Okay. Again, that's another keep. If that's keep, so is this, because it'll be the same expression. Okay, plus negative 4. You need to add 4, just like you did there, to your negative 1. This time x is in front of the symbol. Negative 1 plus 4 is 3. So you have 1 and 3. Give yourself some space, though. I know those are close together, but give yourself some space. So circle, we close it above the 1, but not above the 3. Now it eats x, then it eats a number. Okay. Now you put x, you put 1, you put 3. You're going to eat the 3, then you eat the x. We don't put a line there, but we put a line there. Okay. Okay, next up. Okay, we see double symbols, so that means a table has to be in order. Drop that symbol here and that symbol here. Okay, so start a circle, stop when you get to the other sign. So you put negative 10 and then 3x plus 8. Then start a circle with the 41, then 3x plus 8 and 41. Okay, this time we do have a definite times operation. That's a keep. Now we do have to take out the 8 first, so minus 8 from negative 10, that's negative 18, and we have 3 times x. Now with times we need to divide by 3. So put x where it's at with negative 6. Now the same process takes place over here on this side of the wall. Times, that's a keep. We do have to take out the plus 8 before we divide, so minus 8. Again, the reason it's keep because we divide both sides, but it's by a positive. So 3 times 8, 41 minus 8 is 33. And divide by 3, and you have x and 11. So we have negative 6 and 11. Okay, they're both open. This eats x, so this way. This eats a number this way. So x is any number between there. A between graph we label like this. Eat that number, then eat x. Never goes any other way when it's a between. Okay? Table. Stop the circle when you get to the other side. Okay? Negative 1 less than 3x minus 4. Then put your 14, start a circle, and then you just bring over the expression 3x minus 4. That will be on both sides. See how it overlaps? Okay, wall. You got multiplication by a positive, so that's a keep because later we'll divide, but by a positive. But we do have to take out this negative 4. So plus 4, that's going to be 3. And 3 times x. So then I divide by 3. We have x and then 1. Okay. Times, that's another keep. If that's keep, so is that one, because it's the same expression. So plus 4. Oh, sorry, I didn't keep it. But I do have to take out the negative 4, so 3 times x, and that's 18. Now divide by 3, and you get x and 6. I think I got one of those earlier. So 1 and 6. They would both be open. The 1 we're eating the x, this we're eating the number. So you got x, 1, 6, eat the 6, then eat the x. Okay. Now, what's the deal with those or things? Okay. Well, I mean, I have 2 of these in the same problem. It's already separated for me though. Okay. So here's what I'm going to do. I'm going to make my table, and I just simply copy each one down. I don't have to do those circles. 4x minus 3 greater than 11. When the ors, you don't have to do the circles. They already have 2 separate ones. You don't have to break it up. Now your process doesn't change. The graph's going to look different, but just let's not get ahead of ourselves. So that's a keeper. We do have to take out the -3. So plus 3 plus 3. It's going to be 14. Then divide by 4. And you have x and 3.5. Okay. That's also a keeper. You have to take out the -3 first. So plus 3, that's -8. 4 times x. Now divide by 4. You have x, -2. So we got 3.5 and -2, but you got to look at the board, okay? Now, it's open above 3.5, but closed above -2. Now 3.5, it's eating the x, that goes this way. Here it's eating the number, so that goes this way. So that's an OR, okay? So, on ORs, you just copy down your answers, okay? Go above your 3.5 and just copy that. And then go above your -2 and just copy that, okay? Just copy down what you ended up with. Because you need x on separate ones, but you don't need to do much thinking on the label. You just copy down what you have. Okay, next one on OR. Make 2 tables. On one side we have 7 minus x less than 1. On the other side we have 4x less than or equal to 12. Now we want to be careful here. Not a fan of minuses. Make it plus negative, and you need to put the 1 there if you have a negative. So I think that's a switcherooski. Now I do have to take out the 7. When I'm doing that, I drop down the sign that's up there. So I'm -7, -7, -6, -1 times x. Remember, the sign doesn't change when you minus, only when you divide by a negative, which we are about to do. So when I divide by a negative, the sign flips, 6. Okay, now that was a switch, but one's a totally different one, okay? That's a keep. And I don't have a number I need to take out by adding, subtracting. I just go divide. So I have x and 3. So we have +6 and +3. So you leave the circle open above the 6, but you close it above the 3. So with 6, it's eating x. With 3, it's eating the numbers, so that would go back the other way. So that's an OR. On ORs, you just copy down what you had. Okay, so go above your 6. X greater than 6. Go above your 3. Boom. Okay. Okay, another OR. ORs are nice because they're already separate. I don't have to do the circles. So 3x plus 2 less than -7. -4x plus 5 less than 1. Okay, so we got times, but it's by a positive, so keep it. We have to take out the 2. When you're adding, subtracting, you just drop carry down the original sign, even if you're going to switch it. Then divide by 3. I get x, -3. Now I think that does the old switcherooski. You have to take out your 5, you'll drop that. -4, -4 times x. Now, you are about to divide both sides by a negative number. That's when the sign flips, okay? 1. So I have -3, 1. Both of them are open because neither one of them have the line. Here it eats the -3. With 1 it eats the x. So that's OR, and you just copy your answers. Okay, next one. Same idea. -2x plus 7 less than 1. And 4x plus 3 less than or equal to -5. Okay, you just copy them down. Okay, they're already separated with the OR. Okay, so we got a negative. That's a switcherooski. But first I take out the 7. When I'm adding, subtracting, the sign doesn't change. It's when I divide by a negative. Or multiply by a negative, but I won't be multiplying here. Okay, then divide by negative 2. We have x with 3. Okay, that will be a keeper, because later on in the problem we divide, but it'll be by positive, each side by a positive. Okay, you have to take out your 3. Again, when you're adding and subtracting a number to 0, the sign doesn't change. Remember that one day when we added and subtracted to both sides, it didn't change. Negative 8. And now I have x, negative 2. So I have positive 3, negative 2. Circle, circle. That one, the 3 one's open, but the negative 2 is closed. Okay, x and 3. Let's go there. It's eating the x. Here it's eating the number. Okay. So or, and you just copy down your answers on an or. Okay. When they're, okay, there we go.